In the early 19th century, arsenic ruled the world. It was a major export from Brazil and was used medicinally in China. From common household items like rat poison and weed killer to makeup, clothing, and wallpaper, arsenic was everywhere. Arsenic created an increasingly popular, vibrant shade of green dye known as Shayla's green. Arsenic was widely available, leading to its most infamous use, poison. Its symptoms, including diarrhea, vomiting, and rashes, were similar to common deadly illnesses such as cholera and dysentery. Its tasteless and odorless qualities made it undetectable. Arsenic became known as the king of poisons. But soon, a revolutionary development in forensic science sparked public reactions leading to legal and social reforms. The Marsh test. Until the 19th century, arsenic was the most commonly used poison. The standard test to detect arsenic was simple to use, but unreliable and incredibly dangerous. It required the sample to explode and then release poisonous gas. False positives were common due to elements similar to arsenic, such as antimony. When used for prosecutions, the sample's color would often degrade before the court date, making the reaction anticlimactic. These safety hazards and time-sensitive tests were not practical for court. By the 1830s, a new approach was needed. In 1833, it fell to British chemist James Marsh to determine if arsenic was to blame in the death of George Bodle. A local doctor suggested the Bodle family had been poisoned. Although most of the family recovered, George Bodle died. Sandra Hempel's book, The Inheritor's Powder, details the case.
The Bodle case became a real national obsession in Britain at the time, and people were following it day by day.
Marsh used the techniques available at the time to test food samples collected from the crime scene. Arsenic was present, but the test was not able to determine the amount. Worse still, by the time results were presented in court, the chemical reaction had dissolved. The suspect was acquitted. On the national stage, Marsh had failed. Humiliated and frustrated, he spent the next 3 years creating a test that could not be contradicted in court. This revolutionary new test was easy to understand, versatile, and reliable. When completed, the Marsh test could detect arsenic in food, liquid, or a body, as well as an approximation of the amount. Marsh built on the science of Carl Shayla's test. First, the sample was mixed with acid. Next, zinc was added to the apparatus. The mixed sample was then also added to the apparatus. That produced hydrogen bubbles, and the substances became gaseous. The gas was released and ignited. Finally, a piece of glass was held above the flame. The formation of a metallic film proved the presence of arsenic. The test was not only highly accurate, it could be completed with only a minute sample. The Marsh test was first used in France during the 1840 trial of Marie Lafarge. A year into their marriage, her husband Charles died. His family believed Marie had poisoned him, and she was arrested for murder. The judge employed respected chemist and toxicologist Mathieu Orfila to test Charles Lafarge's organs and food for arsenic, using the Marsh test. The Marsh test was successfully used, and arsenic was detected in Charles Lafarge's organs. On this evidence, the jury declared a guilty verdict, and Marie Lafarge spent the rest of her life in prison.
Marsh came up with his test. There was huge rejoicing, and people were saying some scientific bodies and a pharmaceutical journal, very authoritative academic paper, were saying no one will ever dare use arsenic again to murder anybody. This is the end of its career.
Soon the test was being widely used in crime scene investigation and in criminal courts. The success of the Marsh test in the Lafarge trial led to reforms across scientific and legal fields. A revolution had begun in criminal investigation, and the Marsh test was at the forefront. Propelled by the Industrial Revolution, science and technology were increasingly available to the general public. World's fairs and scientific exhibitions were popular forms of entertainment for both rich and poor. Part of this larger movement, the Marsh test brought the field of toxicology into the public eye, making it more accessible.
The Lafarge trial and its unanticipated consequences helped shape the development and activities of forensic toxicology. The Marsh test would become the chief terror of poisoners as the public trials and method gained public interest and served as a platform for more refined and sophisticated techniques.
Marsh's framework became the scientific blueprint for tests used to detect other metal toxins such as antimony, mercury, and lead. And it inspired the development of tests for non-metal toxins such as cyanide, carbon monoxide, and deadly nightshade. These tests created more confidence when determining cause of death as well as arrests and convictions. Professor Emeritus Gary Patterson explains that the Marsh test met all the necessary criteria of scientific rigor.
It needs to be sensitive, which means you can do it on small samples, and it needs to be persistent, and it needs to be dramatic enough that a jury will say, yeah, that's sufficient evidence for me. So the whole issue of forensic science, sensitivity, persistence, and impact are the three legs of the stool for forensic science. And the Marsh test satisfies all of those.
Arguably, the most important result of the Marsh test was that it highlighted the need for standardized procedures when handling forensic evidence. Before the Marsh test, evidence might be handled by various people and stored wherever space was available. Crime scenes might be unsecured, allowing civilian traffic to muddle evidence. Due to the Marsh test sensitivity, police and medical experts needed to be more conscious of crime scene contamination. This led to procedural reforms regarding access to crime scenes, chain of evidence, and storage. These reforms were revolutionary for crime solving and the use of evidence inside courtrooms. Cases no longer relied primarily on eyewitness testimony. Reliance on the Marsh test changed how lawyers approached their court arguments.
After the Marsh test, the lawyers had to realize that there was going to be evidence that couldn't be contravened. So it changed the expectations from expecting to get off to expecting to get convicted.
Before the Marsh test, juries relied on the opinion of experts to declare the presence of a chemical. With the Marsh test, juries felt that they could more confidently determine if toxins were involved.
It really did. It was a watershed moment when things changed from being really uncertain to being 90% certain.
The public now expected scientific proof in court. The Marsh test was not without its drawbacks. Sometimes environmental or naturally occurring arsenic would be detected. This was especially problematic during the 1800s when arsenic was still regularly found in household items and workplaces. It was also difficult to perform and interpret the results. It could easily result in false positives when elements similar to arsenic were present. Despite its drawbacks, the impact of the Marsh test was immense. It brought significant reform to both crime scene handling and prosecutions. The Marsh test changed not only science, but society on a large scale. Along with reforms to medico-legal sciences, the Marsh test was used to prosecute manufacturers and retailers of dangerous products. Factories were unregulated and workers were unprotected while being exposed to arsenic daily. Cases like that of Matilda Schur used the Marsh test to launch reforms in factory conditions. In 1861, 19-year-old Matilda died of arsenic poisoning. She worked in a factory producing artificial flowers dyed with Shayla's green. By the end, she was vomiting green and stated that everything she looked at was green. The Marsh test provided tangible evidence that Matilda's organs were riddled with arsenic. This led to life-saving reforms for others. A favorite of detective stories, the Marsh test has been used in everything from Agatha Christie's After the Funeral to the more recent Flavia de Luce series by Alan Bradbury. The Marsh test, and the tests inspired by it, have shaped the ever-popular crime genre into what it is today. Toxicology is central to a wide variety of entertainment, from the CSI franchise to the Knives Out series. Interestingly, this has led to the CSI effect, making it more difficult for modern-day detectives and prosecutors. Juries expect to see trace evidence from the smallest sample, even when not realistic. The Marsh test was in use until the 1970s, when gas chromatography mass spectrometry was introduced. Its revolutionary impact on history is undeniable. The test's sensitivity and accuracy changed the way crimes were investigated. Its simplicity allowed juries to draw their own conclusions and changed expectations in regard to physical evidence. It aided in social reform and shaped the way modern consumers think about criminal investigations. When James Marsh developed a simple, reliable test for arsenic, he changed criminology forever. The king of poisons had lost its crown, and scientific evidence reigned.